In this video, we are going to solve the Leetcode problem of the day, and the problem is minimum operations to make a uni-value grid. The problem number is 2033, and first of all, we are going to understand what is the problem all about, then we are going to understand the approach, and then we are going to code it in Python. So let us see what is the question all about. So in this particular question, we are given two inputs. We are given a grid and we are given a number x. The grid is a two-dimensional data and the number x is an integer. What we need to output is the minimum number of operations to make all the elements in our grid equal. So right now you can see the elements of our grid are 2, 4, 6, 8. They are not equal. We need to make all of them equal, and we need to make sure that we do the minimum number of operations to make all of them equal. What's the operation we need to perform is we need to add x, the given x in the input, to a number. That is, we have a number in the grid 2, 4, 6, 8. We can either add 2 in it, or we can subtract 2 or whatever x is given in the input from the number. So whatever the numbers are given in the grid, we need to either add x or remove x from a given number and make them equal. And we can perform this addition and subtraction any number of times. And now, based on the given operations, how many operations will you take to make all of them equal? So right now you can see for this given input, the output is 4. How it is coming? So we have 4 numbers and we have to make all of them equal. And the numbers are 2, 4, 6, 8, right? And for now, let us choose that we need to make all of them equal to 4. So what you will do to make 2 equal to 4, you will have to add 2 in it and this will be equal to 4. Why are we adding 2? Because the given number x is 2. Next is how many operations you will take to make 4 equal to 4. So no operations required, right? So it will be 4 only. Now to make 6 equal to 4, you will have to minus 2 into it. So it will be equal to 4. And to make 8 equal to 4, you will have to say minus 2 and minus 2 two times to make sure that it is equal to 4. And now if you will count the number of operations which you did, it's 1, 2, 3, 4, and the output is 4, right? So this is the logic. This is how they are doing it. This is how they are processing the input, and after processing they are giving a output. Now let us see a scenario where you make all of your numbers equal to 2 and not 4. Then how many operations will you be required? So let us get rid of this and let us try to make all of them equal to 2. Now to make 2 equal to 2, you don't need to perform any operations. So this will be 2. To make 4 equal to 2, you will have to say minus 2 into it, and this will be equal to 2. Why minus 2? Again, this is because the value of x is equal to 2. If the value of x would have been 3, we would have been trying by adding 3 and removing 3. Okay, so it's all about the number x. Okay, now to make 6 equal to 2, we need to say minus 2 and minus 2, and this will be equal to 2. And to make 8 equal to 2, you need to say minus 2, minus 2, minus 2, and this will be 2. Because 8 minus 2 is 6, 6 minus 2 is 4, 4 minus 2 is 2. Okay, and the number of operations which are performed is 1, 2, 3, 4, 5, and 6. So we took 6 operations to make all of the elements in our grid equal, and that's equal to 2. And the thing is, we can make them equal to any number of our choice. It's just that we need to make all of them equal. You can even choose to make all of them equal to 10, but that's going to take more number of operations. And we have to return the minimum number of operations to make all of them equal. So making them equal to 10 or 2 or 6 is possible, but there is a problem. That's not the minimum number of operations. For this case, making them equal to 4 will give you the minimum number of operations. Now there is one more catch. There can be a chance that you are not able to make them equal. And in that case, the output is going to be minus 1 if you are not able to make them equal. Okay, what can be that condition? Let us see. Now let's assume that instead of 2, this number is equal to 3 and x is the same, 2, x is equal to 2. Now you can try to make any number of operations and you will not be able to make them equal, and in this case the output is going to be minus 1. So let us try to understand this situation. We are having 4 numbers, 3, 4, 6, 8. So instead of 2, we took 3. Okay, the value of x is 2. Okay, now try to make them equal. So for now, don't focus on 6 and 8. Okay, just focus on two numbers. Let's say the given input is 3 and 4 and the given value of x is equal to 2. So in this case, can you make them equal? That's the question here. Can you make it equal? No, we cannot make them equal by doing any number of operations, because if you try to add something to 3, 3 plus 2, this will be equal to 5. Okay, that's not equal to 4. Okay, let's try to do some operation on 4. 4 plus 2 will be equal to 6, but and 4 minus will be equal to 2. We need 3 or 5, right? So here you will notice some pattern that if the initial value is 3 and 4, then it can be converted to 5, 7, 9, or instead of adding, you might try to subtract the number x. So then in that case, 3 will become 1 minus 1 minus 3 dot dot dot, right? But the value of 4 can be, if you try to remove the value of x, then it will be 2, 0, minus 2, or if you try to add the value of 2 or the given x, then in that case it will be 6, 8, 10, right? So here you will notice that try to do anything, but they will never be equal. So if you cannot make two elements equal, you don't need to check further. You can directly say, hey, say the output is minus 1, and the reason is we will never be able to make them equal. Now let us see what is the solution approach for this particular problem. It's going to be very easy after understanding the approach. So let us focus on it. See, so let us understand the approach. See, the first important point here is, now since we need to make all the element equal, instead of a grid, we can treat the grid as a one-dimensional array. So if you will notice here, the original input was 2, 4, 6, 8. And if you try to do any operation on these numbers, you will notice that doing the operation on the first row or the second row or any column, right, is the same. You are performing some operation on this given number 4 or given number 6, it doesn't even matter which column or which row they are belonging to. So we can treat them, instead of a grid, we can convert them to a one-dimensional array, 2, 4, 6, 8, right? And perform our operation on this particular data. So that's the first thing we are going to do. And this is going to make the solution easy. And that is why we are going to do it. Now, next is, think about when it is impossible to make them all equal. First, try to think, is it possible to make them equal or not? And the reason is, if it is not possible, then you don't need to go further. Just directly return minus 1. So how can you think about it when it is impossible to make them all equal? So we talked about an example where we had two numbers, 3 and 4, and the x was 2. And we saw that we cannot make them equal. Technically, how can you find it? If you try to find the mod of these numbers from the given x, they will never be equal. Let us see. 3 mod 2, this will be equal to 1. And 4 mod 2, this will be equal to 0. If the mods are not same, you cannot make them equal, and the reason is, this factor, the remainder factor, will always be there if you are adding or removing something. And since the remainders are not same, you cannot remove this difference. Let us take another example to understand this. Let us say we have two numbers, 1 and 5. Now in this case, these numbers are odd, right? But still we can make them equal. Plus 2 and plus 2, this will be equal to 5. Both are 5, right? And now if you will notice that 1 mod 2, this is equal to 1, and 5 mod 2, this is equal to 1. The mods are same, and that's why they are possible to make them equal. And again, the reason is they have the same remainder factor, and if you will add something in it, the remainder factor is not going to change because they are already equal. So we can make them equal by performing some operations, right? So the next question is, if it is possible, choose the best number in which all other numbers needs to be converted, and that's it. So if it is possible, you just need to find the best number in which you need to convert all the other numbers. Okay? So let us see how we can do it. See, the given input was 2, 4, 6, 8. Here, if we choose 4, we are getting the output as 4. But we did saw a scenario in which we chose, okay, let's make all of them equal to 2. And in this case, the output was 6, which is not the correct output because 4 is the correct output. So choosing the best number, choosing the number in which we need to convert all the other numbers is very important. Now let us try to understand what's the best number and how to choose it. So let us take this example as a scenario. So we have four numbers, 2, 4, 6 and 8. Let us try to draw them on a line. We have a number 2, we have a number 4, we have a number 6 and we have a number 8, right? Now let us try one by one with all the numbers. So if you try to make all of them equal to 2, in this case you will notice that 4 need to move left side, 6 needs to move left side, and 8 needs to move left side. And that's the total distance we need to travel in case of 2. In case of 8 as well, you will notice that 6 has to move right, 4 has to move right, and 2 has to move right. But what if we are choosing 4? So in case of 4, you will notice that 2 needs to move, 6 needs to move, and 8 needs to move. But this time, if you will notice, the distance is less traveled. And for 6 as well, you will notice that 8 has to move, 4 has to move, and 2 has to move. Again, the distance as compared to 2 and 8 are less. So now we can observe a thing that if we try to choose something which is in the middle, then the number of operations are going to be reduced. This is because all the other numbers are going to converge to that mid number. But if you try to take some extreme number, In that case, all the numbers need to move and this will increase the distance, right? The last number to go to this place will take a lot of distance and that is lot of operations. It means that we need to make sure that our elements are sorted and we need to choose the middle number out of it, and that will be our target number, and then we will try to find out how many operations we will take to make all of them equal to our target number. So that's the approach. Let us try to jump back to our code editor and try to code it using Python. Okay, so we are on our code editor, and the first thing which we need to do is we need to make sure that this grid is two-dimensional. So let us convert it to one-dimensional. For that, we can use list comprehension. Grid is equal to, so, and let us run a loop on the rows. For row in grid, and then for column in row, we need to add the value of column here. So this will convert our data into one-dimensional array of 2, 4, 6, 8, or whatever the numbers are given. And then we are going to sort it. We can store the result equal to 0 initially. And now let us initialize two values. The remainder of the first number with the value x. So remainder of the first number is grid of 0 mod x. And then what's the mid value? So the mid value is equal to grid, whatever the length of the grid is, and then divide the length by 2. This is going to give us what's in the middle when we sort our array. And in the terms of mathematics, this is called median. So we are trying to find out the median value here. Now let us run a loop in the grid. So we will say for t in grid. And now inside this loop, we need to run two operations. Check if it is possible to make all of them equal. So for that we can say if t mod x is not equal to rem, and then we are going to return -1. We can make our result. So result is equal to result plus what is the difference between the number d and the mid value or the median value, and we need to divide them by x. And we also need to make sure that we are taking the absolute value, because this can be negative or positive, but we need the absolute number. Once we have stored the result, we just need to return the result. So once we have our result, and if our loop is not returning -1, then it will return the result. So we can say the return result here and then submit the code. Wait for some time and this should solve your question. Yes, this solved our problem, and that's the complete code. And it's a very clean code, right? We just converted our number into a flattened array, sorted it, found the remainder and the mid, and checked for the possibility and stored the solution and returned the result. So it's a very straightforward code after we understood the approach. So I hope you understood about the approach. That's the very important thing here. And also I hope that you gained something from this video. And if you did, then make sure that you hit that like button. And if you're not subscribed yet, make sure you subscribe the channel as well. And I will see you guys in the next video. Thank you for watching, guys.